Hi everyone, I am N.R. Bhuneshwari, Associate Professor, Department of Mathematics, SNS College of Technology. Today I am going to deliver a case study on Z transforms and its applications. Explanation of Z transform. Introduction. The definition of Z transform. The Z transform of a sequence UN defined for discrete values n is equal to 0, 1, 2, 3, etc. and un is equal to 0 for n less than 0. This is denoted by Z of un. Z is denoted by Z transform. Un is sequence un and is defined as Z of un is equal to summation n is equal to 0 to infinity un z power minus n is equal to u of z, where u is a function of z. For every application of Laplace transform, there is a corresponding application for the Z transform. Few applications of Z transform, which is used in system designing, used in find out stability of a system, used to find frequency response of a signal, analysis of linear discrete system for designing digital filters, which are common uses of discrete Z transform. Now, let us see a real life application using the concept of design thinking. Before that, just we know that what is design thinking? Yes, design thinking is a non-linear iterative process which seeks to understand users, challenge assumptions, redefine problems, and innovative solutions to prototype and test. These are the 5 stages of design thinking. The concept of design thinking explains the suitable solution for the solution problem given below. Here the figure shows a motor and gear train that we might use in the servo system. That is motor given, gear given, and here the difference equation that describes the plant might look like xn is equal to a plus 1 of xn minus 1, which is for motor, minus a xn minus 2 is for gear, plus b un minus 1 is proton meter. Empathy. To understand the given problem, to analyze the given equation. We define this empathy part to understand the provided data, that is the given figure and the equation, narrowing them to algebraic equations which will help to solve the problem using Z transform concept. Ideate. We can take Z transform of the following behavior equation without knowing what xn or un and get it. X of z is equal to x of z of 1 plus a z power minus 1 minus x of z a z power minus 2 plus u of z b z power minus 1. Notice a cool thing. We have turned the difference equation into an algebraic equation. Yes, this is one of the many things that makes the Z transform so useful because we can now easily solve the algebraic prototype. By using transfer function, the function h of z is called the transfer function of the system. It shows how the input signal is transformed into the output signal. That is, h of z is equal to y of z by x of z. In Z domain, the transfer function of a system isn't affected by the nature of the input signal, nor does it vary with time. We can predict the behavior of the motor using h of z. Let's say we want to see what the motor will do if x goes from 0 to 1 at time n is equal to 0 and stays there forever. This is called the unit step function, and the Z transform of unit step responses is h of z is equal to z by z minus 1. Thus, we can know everything about the system behavior and avoid undesirable situations. Conclusions. We have concluded that Z transform is useful for manipulation of discrete data sequence. It has acquired new significance in the formation and analysis of discrete time system. In today's world, it is mostly used in applied in mathematics and digital processing.